Good day to all the panel and greeting everyone. I'm Tan Yen Fang, a final year student from FYP1 Biomedical Electronic Engineering in UNIMED. Today, I would like to present my final year research with the title of Severity Classification Using Deep Learning for Diabetic Retinopathy, and I am supervised by Associate Professor Dr. Haniza Yazid. So this is the thesis presentation outline that I'm going to present today, which consists of introduction, literature review, methodology, and preliminary results. So first, let's begin with introduction, which consists of background of study, problem statement, objective, scope, and expected outcome. Diabetic retinopathy is a condition with a progressive retinal damage caused by a musculovascular complication of diabetic mellitus, which will eventually result in vision loss. Diabetic retinopathy is the main cause of blindness worldwide, and this will be supported by World Health Organization as stated that more than 75% of the patients who had diabetic mellitus for more than 20 years will have some form of diabetic retinopathy. And also according to the National Eye Survey in Malaysia, diabetic retinopathy caused blindness in 10.4% Malaysian older person. The problem statement for this study is that the diabetic retinopathy is hard to be detected in the initial stage, and it is tough and time consuming by using the manual method to identify and get the detail of fundus images, as it takes around 3 weeks time to get the result of the severity level of diabetic retinopathy. So by using the manual method to get the severity level of diabetic retinopathy can be time consuming even for the experienced expert. Besides, based on these images, we can see that there are a few problems surfaced during the process of analyzing and interpreting, as there are a noise and artifact present in the images due to the involuntary eye movement. However, this problem can be overcome by using the image preprocessing technique. So there are 3 objectives for this study. The first objective is to investigate a suitable image preprocessing technique for fundus images. And the second objective is to implement a local entropy thresholding to segment the feature in the fundus images. And the last objective is to classify the severity of diabetic retinopathy based on entropy images. So the scope that's covered for this study would be the sample retina fundus images are collected from several datasets available online, such as Kaggle Optos 2019 and DirectDB1. Although there are 2 main forms of diabetic retinopathy, which are non-proliferative diabetic retinopathy and proliferative diabetic retinopathy. However, for this study, we just focus only on non-proliferative diabetic retinopathy as it contains the earlier sign of diabetic retinopathy. So that the information collected include images of normal eyes as well as the images of mild, moderate, and severe cases of non-proliferative diabetic retinopathy. Besides, the programming language that used in this project is Python and IDE software. So there are 2 expected outcomes for this study. As I mentioned before that the conventional method to identify and get the detail of the fundus images is time consuming. So the first expected outcome for this study is to have a fast and reliable system will be developed to classify the severity level of diabetic retinopathy. And the second expected outcome is to have the performance of the deep learning model will be more than 90% accuracy. So now let's move on the literature review. According to the International Clinical Diabetic Retinopathy Disease Severity Scale, the severity level of diabetic retinopathy is based on the number and size of lesions present on the surface of the retina. There are 2 main forms of diabetic retinopathy. Non-proliferative diabetic retinopathy, which also called it NPDR, is the earliest stage of diabetic retinopathy. There are 3 main stages to this type of retinopathy, which include mild, moderate, and severe NPDR. For the mild NPDR, the fundus images might contain the microorganism only. However, for the moderate NPDR, it may contain multiple microorganisms, hemorrhage, and cotton wool spot, but less than severe NPDR. For the severe NPDR, it might contain the cotton wool spot, venous bleeding, and severe intraretinal microvascular abnormality, which also called it IRMA, in 1 or more quadrants. However, for the proliferative diabetic retinopathy, which is the later stage of diabetic retinopathy, it might contain the abnormal blood vessel, and the scar tissue may grow on the surface of the retina, and this situation is known as neovascularization and vitreous preretina, and it might also contain the hemorrhage in the fundus images. However, for this study, we only main focus on the NPDR as it contains the earlier sign of diabetic retinopathy. Besides, each of the retinal lesions present due to the diabetic retinopathy has their own property. In NPDR stage, there are 4 main types of the retinal lesions might be present, such as microorganism, hemorrhage, hard exudate, and soft exudate. Microorganisms are reddish in color, smaller in size, circular in shape, and diverse on the superficial retinal layer. For the hemorrhage are called dot plot, they are similar to microorganisms. Dot hemorrhage are small red dots, whereas the blood hemorrhage are bigger red lesions. For the heart exudate, so as a bright yellow spot with irregularly shaped on the retina. Meanwhile, for the soft exudate, often known as cotton wool spot, so as yellowish white fluffy spot caused by nerve fiber damage that usually occupy an area less than 1/4 that of the ophthis. And based on this figure, we can see that microorganism and hemorrhage are seen in the dark lesion. However, for the hard exudate and soft exudate are seen in the bright lesion. So based on the written paper that completed by the peer researcher on automated detection of diabetic retinopathy, and based on the several steps which include preprocessing, segmentation, and classification. For preprocessing step, most of the researchers propose that the most suitable image enhancement technique is contrast-limited adaptive histogram equalization, which is also called CLAHI, as it provides the ability to highlight the region of interest. Besides, in order to filter the noise from the image, most of the researchers propose that by using the median filter, because it not just filter the noise, but still preserve the detail of the edges from the image. Meanwhile, for the segmentation method, we can see that most of the researchers propose that the most suitable segmentation method is the thresholding-based segmentation. In addition, for the classification part, most of the researchers propose using the deep learning-based methods such as convolution neural network in order to classify the severity level of diabetic retinopathy. So from this table, it shows that each of the deep learning methods scoring detail. And it also shows that the deep learning method is suitable and efficient method in order to classify the severity level of diabetic retinopathy because each of the method accuracy is more than 90% and above. Let's move on to the methodology part. Each of the methods that implemented throughout this study will be discussed in this chapter. But before I start to explain the flowchart of the pre-processing, segmentation, and classification, I would like to make a data retrieval. As I mentioned before, there are two datasets will be collected. The first dataset is covered up to 20 and 19 years, which contains 3,662 high-resolution photos collected by Arvind Eye Hospital in India rural areas. And the second dataset is direct DB1, which contains 89 color retina fundus images, 84 images that belong to the mild, moderate, and severe level of NPDR, and 5 are considered normal, with no sign of diabetic retinopathy based on the mean visual observation score. So there are a total of 3,751 retina fundus images selected from each stage and applied in this study. So now I would like to make a brief introduction about the whole process that involves preprocessing, segmentation, and classification. First, each of the fundus images will be separated solely into a 3-color channel, and the 3-color channel in the RGB image is fixed to be red, green, and blue. After that, this image will be passed to the pre-processing step. In the pre-processing step involve the image enhancement and image filtering method. After that, we'll pass to the segmentation step. In the segmentation step, local entropy thresholding-based segmentation method will be used, and we get the entropy image. If it is satisfied, it will pass to the convolutional neural network and do the classification. If it is not satisfied, it will pass back to the pre-processing technique again and then do the whole process again. First, I would like to explain the input of the RGB image. So this figure shows that the original image and the image in red plane, green plane, and blue plane. So from this figure, it shows that the green plane of the RGB representation shows the maximum contrast between the lesion and the background. However, the red channel is often saturated and has low contrast, and the blue channel is very noisy. So for this reason, the image in the green plane is commonly used as an input to the image enhancement process. An image is said to be low contrast when there is no much difference between the bright and dark region. So contrast adjustment is needed in order to enhance the low contrast image. So in this study, there are 3 types of the image enhancement technique will be used, such as histogram equalization, contrast-limited adaptive histogram equalization, which is also called CLAHI, and lastly is the unsharp masking. So after the image filtering process, we will pass the image to the segmentation step. So in order to segment the region of interest from the image, the local entropy thresholding-based segmentation methods is used in this study because of its high computational speed and simplicity of implementation. So what is meant by local entropy? Local entropy in an image refers to the complexity contained in a certain neighborhood, which is often determined by a structuring element. The entropy filter can detect a small changes in the gray level distribution in a given area, and the value in the entropy image are derived locally from n times n blocks. Besides, the entropy is a function probability distribution of the local intensity. And the equation below represents the value in the local entropy image for the input of the proposed convolution neural network. Within a m times n block, Pi denotes the relative frequency associated with the eye phase level. So after the segmentation process, if the entropy image is satisfied, we will pass this image to the classification using the convolutional neural network. So basically, there are 5 layers in the convolutional neural network. The first layer is the convolutional layer. This is the first and foremost layer that after the input image, we want to be classified. And the second layer is pooling layer, the maximum pooling layer which extracts the most important value from the window, but trade the average of the value within the window size with the average pooling layer. And this is one of the most significant layers which help the network from avoiding overfitting by reduce the parameter and computation in the network. And the third layer is the dropout layer. The crucial part of the deep convolution neural network is handling the parameter generated from each stack layer abundantly. It must cause overfitting. For avoiding such scenario happen, dropping out some neuron in the layer which cascaded to the next layer. So usage of the dropout mainly near fully connected layer to avoid the excessive generation of parameter, and it is widely used for regulational technique. After the dropout layer, it's come to the full connected layer. So actually what is meant by fully connected layer? Actually it is the layer which comes after the cascaded convolutional and max or average pooling layer is called fully connected layer. And the high level reasoning is done through this layer during the classification. And the fully connected layer takes all the neurons in the previous layer from max pooling layer and connect it to every neuron it has. And lastly, the full connected layer are not spatially connected anymore. It visualized as one-dimensional layer. And the last layer is the softmax layer, which also can call it classification layer. So after the stack of the deep multiple layer, the final layer is a softmax layer, which stack at the end of the classifying the fundus images followed by the fully connected layer output. So after the whole process being done, we need to do the performance measure as in order to evaluate the technique and the deep learning model used. So the first one is the peak signal to noise ratio, which also called as PSNR. So actually PSNR is commonly used to determine the efficiency of image enhancement technique on the image quality. And the equation below shows that the mean square error is calculated in order to compute the PSNR. Beside the L is the number of the maximum possible intensity level in an image. So in overall, PSNR is commonly expressed as a logarithmic quantity using the decibel scale. And beside, accuracy, sensitivity, and specificity are the common method to determine the performance of the test, especially in binary classification tests. So for the accuracy is being evaluated from all dimensions of true and false positive negative is stated as is in equation below. And the second one is sensitivity, which sensitivity is the ability to predict or classify one category correctly. And mathematically, it is proportion of the true positive which being identified by the equation below. And the third one is a specificity, ability to identify the other group of objects which different with the group of sensitivity. And it can be calculated through the proportion of true negative with the equation shown in the equation below. So basically, the true positive means the correctly detected diabetic retinopathy images, and the true negative means that correctly detect non-diabetic retinopathy images. However, the false positive means the number of the non-diabetic retinopathy are detected wrongly as an diabetic retinopathy images. And the false negative means that the number of the diabetic retinopathy images detected wrongly as a non-diabetic retinopathy images. So now let's move on to the preliminary result. As I mentioned before that the image preprocessing step is necessary in order to reduce and eliminate the noise and artifact that are present in the fundus images. So the image enhancement technique will apply for the fundus images before undergo the segmentation step. So this figure shows that the original image and the image after apply the contrast adjustment technique. So for the original image, we can see that the original image has the low contrast. But for after apply the histogram equalization with the unsharp marking, we can see that the image is being enhanced, but some part of the image are being over contrast and make the feature can't see very clearly. However, for the Clahi with the unsharp marking technique, we can see that it not just only enhance the image, but also help to improve the outline boundary of the images. Besides, by comparing the PSNR value of these two techniques, we can see that the Clahi with the unsharp masking has the higher value. And it proves that Clahi with the unsharp marking is the ideal type for the contrast adjustment. So now let's move on to the FYP1 Gantt chart. So this table shows that the things that have been done for this semester. So I read done on research and review a related article, report writing chapter 1 and 2, research methodology, report writing chapter 3, and conduct a pre-processing on the fundus images, and also the preliminary result analysis, and also done on the final report submission. For the next semester, I plan to do improvement on the segmentation method and start to classify the images using the convolutional neural network model, and do the performance analysis and continue the thesis writing. So this is all the reference that I've been referred for this study. So that's all from me today, and hope you enjoy my presentation. Thank you.